In a moment. Okay. Shh. Shush. Trig. Trigonometry is all about ratios. And what early mathematicians discovered is that angle that we were just talking about, that marked angle, theta, that we're talking about there in question 1, has a relationship to the three sides. And has a ratio relationship to those three sides. So if we remember back to the end of last term, my class especially, when we did similar figures, in a minute, Paige, we did similar figures. And when we looked at similar figures, we know that all the sides in a similar figure, especially similar triangles, are of the same ratio, yes? When we enlarge something or make it smaller, those all three sides enlarge or become smaller in the same ratio. And that's what made the figure similar. All the angles become the same. In trig, we actually study those special ratios, because we have really three ratios we look at. Opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. So we look at those three particular ratios and work out what they actually tell us about that particular triangle. And those ratios can tell us something about the angles. So what we're going to be doing now is this worksheet. And I hope I've now got enough sheets in here. So, on this worksheet, what you need to do is, first of all, label our triangle. And I'm just going to go back to my... So this is question 180 you've got. Shh. Can you listen? Shh. Listening. So this is our triangle. All we've done is created these lines in there, and so we know that each of these triangles is similar. Why? Because these angles here are the same, because they're all 90 degrees. This angle is common, it's 30 degrees, so therefore each one of those angles must be the same. If we were to label this triangle, these sides over here are going to be the hypotenuse. Why? Because they're opposite the right angle. Here's our marked angle down here. So that one over there is going to be opposite. So all of these sides in there are going to be the opposite side. And all these sides down the bottom here are going to be our adjacent side. So what you need to do for this particular triangle is measure the distance from there to there. So this is triangle number 1. Notice how they've got B1 and C1 there. So that's triangle number 1. So the hypotenuse for triangle number 1 is the distance from A to C1. The hypotenuse for triangle 2 is from A to C2. Hypotenuse for triangle 3 is A to C3. And so forth. And then we need to do the opposite side. So we need to measure B1 to C1, then B2 to C2 for the various triangles. Then we need to measure the adjacent side. So A to B1, A to B2, and so forth to get those. Then remember I talked about 3 ratios. The opposite over hypotenuse ratio, the adjacent over hypotenuse ratio, and the opposite over adjacent ratio. So what I want you to do then is work out the value for each one of those ratios. So here you just do opposite on your calculator, the opposite value divided by the hypotenuse value. And whatever the answer comes out, will come out as a decimal, you write the decimal in there. I'd go to 3 decimal places at the moment. Okay? So that is question 1. So I'd like you to do those ratios to 3 decimal places. I'd actually just like you to write the answers in there. Some of you are writing the fractions, which is fine. I don't mind. I like fractions. But when we do the next bit, we're going to be needing the decimals. So just extend that on there and just write them in. Okay? Does everyone understand what you're doing? Yes? Okay, get to work. I'll be there in a tick, Adam.